right, good evening. I think I'm there. I think just checking the sound here for a second. Let's see if this is right. Test, test, test. If you guys can hear me, can just give me a hello. Be helpful. All right, let's talk about something different when it comes to Assetto Corsa Competizione. Hopefully the sound is there. Let's get this thing rolling. Just do a little bit of get the lights, camera action on the cars here. I love the way when they start up here. Should be. It's just cool when the night racing and all right, let's talk about something different. Night racing and the Assetto Corsa Competition is just, especially this dusk time frame, is just amazing. Lights on, cars taking off. We're not going to be doing a whole lot of racing. I'm going to be talking about physics, but it's always good to start a race off with racing, or at least a simulation of racing off with racing. So I love this part of Brands Hatch. I mean, the graphics are so phenomenal. You see the lighting, how it's just shadow, shadow lighting, shadow lighting, shadow lighting. The sights and sounds of Assetto Corsa Competizione. I know many people love Assetto Corsa, myself included, but I do think this is another level of sim racing. I'm really into the realism of it. I don't care so much about game modes. I think there's plenty of games out there like Forza, which I like too, but for me it's all about the feel, how the car drives. Can I get the most out of it? I have a Porsche and I know how Porsches drive. And 2018 718 Boxster mid-engine, just an amazingly fast car. For me, it's amazingly fast. I can't even imagine how I could ever want anything faster. I mean, at 130 miles an hour, it feels like I'm driving 55. So I really have to be careful how hard I push it. Anyway, just saying all that to say it's all about the physics for me. So let's get into this. So 107, 106 is out. ACC's been out, I guess, May 29th. So June, July coming up will be 2 months. 106 is out. Quite a few changes were made in 106. 107 is about to come out. And they're talking about a breakthrough in tire physics and some other things associated with that. So I am going to show a document. I'm going to attempt to show a document here and kind of walk through some of it, and then we'll jump back and forth to the racing. I'm not really a streamer. I'm just doing this because I love this sim so much, and I want people that enjoy racing to experience it. So, in fact, I might leave the cars up and just because it's pretty technical. So if you are a technical person, you might enjoy this. If you're not a techie, this may not be your alley, but this is pretty significant. So let's talk about where we came from. So one of the developers talks about sort of the trade-offs of modeling a car. And it really comes down to, you want it to be very fast when you're sim racing. You want it to be as accurate as possible, and also low resourcing. Use low resources, as we've all seen. As these sims come out, the demand on resources has gone up. So the developer talks about how he could only choose two. These cars are modeled on a 3D mesh with millions of polygons. Add to that they've gone out and laser scanned these tracks. And it's just a whole lot of data crunching that goes on to just get the car around, model collisions, model everything. So On top of that, the tire modeling is a high demand item. Obviously, since that's what really connects you to the driving of the car, or how it feels to drive the car, or how you can push it. It's just probably maybe one of the more important elements of what a sim racing solution could bring. And the tire model is quite complex. So they talk about, they said, as a matter of fact, the ACC tire model is one of the most evolved, completely dynamic, with a wide range of causes that affect and influence the grip and response of the tire. Various heating levels, different tire wear features, various influences like tire rigidity, the damping, tire wear, how hard is the tire, completely dynamic slip ratios, the angle the tire is on, whether it's a wet or dry track, the dynamic rolling resistance, different situations such as when you have full water draining and heavy rain. So a lot of variables create a lot of complexity. And they started to notice with the advances in Assetto Corsa Competizione over Assetto Corsa that they started to see some issues that became a little bit buggy. But the good news is I think they have found a breakthrough for both sims, Assetto Corsa and Assetto Corsa Competizione, that will affect the realism of both solutions. So I'm going to talk about a few examples here. Let me go down to one of the examples they talk about. So here's the deal. The deal is that the tire model used in Assetto Corsa and Assetto Corsa Competizione today uses a single point of modeling per tire, so 4 points to model the tire. Now you can just imagine, if you start thinking through the different scenarios, what that might, it'll obviously help with performance because you don't have to take all of those variables I talked about, tire heating, tire wear, water draining, etc., so many times. But what about issues when, part of the tire's on the ground, part of the tire's in the air, part of the tire has come up against a bump, but the back half of the tire still has full grip. So you get into things like that. So one of the examples that they talk about is at Spa, where the curves have around some of the curves have around a 30-degree or higher angle. And with the wide tires of these GT cars, you could have part of the tire, the inside, let's say you're on a 30-degree angle turn, a curve, the outside of the tire may lift the inside of the tire off the ground in real life. But if you're only measuring from a single point, there could be specific issues associated with that. You'd have, I think it's common knowledge in sim racing that you really don't want to be on the curb as you exit the turn, because you want to be able to press the gas full speed. So, or at least you have to kind of modulate the throttle until you have complete friction. But in reality, you could have the back half of the tire still on the curb and the front half of the tire in full contact with the road, and you could get more grip associated with that. So a couple of examples. Hope I didn't lose all my highlighting I did here. All right, so that's the Spa example of a 30-degree turn. At Paul Ricard, they tend to have, apparently the corners tend to have drop-offs. So you'd have the flat surface and then like a 2-inch drop-off into sort of a flatter area, which could have bumps in it that might go up or down. And in that case, again, you could have it'd be even more pronounced where you would have part of the tire on the track and part of the tire hanging over the edge of the bump, of the curb. So he says another example are step curves. As you can, the following, let's see, he talks about par Ricard. The steps of the curve are not equal from side to side, but gradually become more and more deep. The tires of a GT3 are quite wide, around 30 centimeters. This means that often the tire can be over the curb with the outside part over the more shallow part of the step and the inside part over the completely flat part of the curve, leaving only the center of the tire hanging through the most deep part of the stepped curve. In real life, you would feel the vibrations of the curve, wouldn't be that important, but with simulation, a single contact point, as we've been talking about, you would only be able to detect and model a single point of impact of the tire. So you sort of get a less than perfect modeled solution. So it's actually not, it's actually better in real life than it is in the simulation model. Then they talk about scenarios where you're coming out of a curb and if you had more points of contact, you really would have traction. But because you don't have traction, you might end up in a spin and things like that. Or they something called the curb of death situation. What the curb of death situation is that often a driver will ride and go over the edge of a curb and then slowly return to the main road, going almost parallel to the curb. ACC in particular is extremely critical in such situations, adding full 3D flex of the contact point, of the tires flexing up and down. There's a lot of special modeling they do. In AC, Assetto Corsa was only vertical. In ACC, it's a 3D flex. The tire can move from side to side and up and down, forward and backward. The flexing part of it. But so having this 3D flex created a critical condition in the above scenario. A single contact point would go to the vertical parallel side step, and being as high and vertical instead of climbing over it, it would start to flex outward, practically getting trapped in a rail. The driver would see the car, that the car wouldn't follow his commands and re-enter at some point. He would move the steering wheel more and possibly get into a spin. So I know it's sort of, he's being a little bit critical of the current state of ACC, but this is so more far advanced than anything that's out there. But this story gets really good. So 1.07, which is not out yet, coming out probably in a couple of weeks, now features a 5-point contact model. We implement 2 contact points at the edge of the front of the tire footprint, 1 in the middle of the footprint, and 2 more contact points at the edge of the rear of the footprint. Each single point moves and flexes independently, reacting on forces and surface contact, but also predictably, I think there's a typo in this, forces to move the other points together, averaging the resulting forces and vectors, giving a much better representation of what the actual tire would do. So if we go back to the first example at Spa, where there is a smooth, say 30-degree or so curve, what happens in this case where you now have 5 points being looked at against all of those things I talked to you about earlier? On the first smooth high curve situation, the advantages are multiple. First of all, when the edge of the tire touches the curb, it activates the sound and properly moves the force feedback of the steering wheel. So remember, before they only had 1 point in the center, so you only got force feedback when that center point reached a point where the force feedback threshold was met. In this case, there are 5 sensor points. So thus, the force feedback is communicated to the driver with the correct width and position of the tire. Furthermore, the contact points at the edge of the tire get the spike of the steep angle of the curve, but the forces are averaged to the rest of the contact points that are still on the flat surface. So the tire meets the threshold of force feedback much faster on the part that's hitting the 30% angle of the turn of the curve, and the stuff that's flat, I'm sure they're probably it talks about averaging the other points because it's sort of critical data points, just a flat thing. But of course, tire slip from water, I'm sure would matter as well. But it's just interesting that they're modeling it that way. The tire actually climbs over the curve instead of instantly finding itself on top of it, which is the point where you only have one single point. You're either on the road or you're on the curb. In this case, all of the data points or the sensors are averaging the tire movement across the rise of the curve. So when you only had one data point, you basically went from, it's kind of like binary, you're 0, 1, you're either on or you're off. In this case, you sort of slowly climb up and you get the force feedback associated and the detail of that force feedback associated with that. On the second example at Paul Ricard, where the curbs can actually have a step, kind of can be flat, the road can be flat and it kind of falls off for 2 inches or steps up for 2 inches, sort of a square type curve. The contact points now include the whole width of the tire, and if that's the case, successfully keeping the middle of the tire in the air while also being spread longitudinally in the footprint length. So this is the case where on the outside of the track they have sort of the bumpy area, but the bumpy area can be parallel to the track but can drop, so the front of the tire would be sort of going off the edge and the back of the tire would still have traction. If you only had one single point, you may not pick up on that. So in that case, if you're about to go over the edge, kind of the cliff, I'll call it the cliff model of small ups and downs in the off part of the track, there's always a contact point touching the surface at the front or the rear of the footprint, even if the tire is rolling on the steps. On top of that, the extra points are controlling for load spikes and avoid situations of excessive rolling resistance or vectors that point backwards to the car motion. So having a better model averages it, because you could have, if you only had one point and that point hit a bump, it could actually sort of be going against the direction of the car. They say that this greatly is improving the acceleration over stepped cars, as an example at the exit of turns, which in the past the driver would avoid in order to not harm their acceleration. So you sort of have traction earlier as you exit the turn. So see if there's another interesting part here. Just checking to see. All right, so going back into this, we're almost through this. There's a couple more points that I thought were really cool. I'm an engineer by education, and I think this is really, really innovative what they're doing here. So as an extra bonus, we have also added a new dynamic feature to the tire flex behavior. So he's saying, look, our tire flexes in 3D, so forward, backwards, sideways, up and down. Going even further, in the tire simulation, if the tire has a lateral flex, it actually will lower the tire a few millimeters. That means that the more the tire flexes laterally, the more the ride height lowers. Obviously the change in ride height is minimal, but the car with proper simulated aerodynamics, we know that even 1 millimeter is important to aerodynamics. So that, as the tire flexes laterally, you could have a ride height change, and they've modeled that into the car. So it gives a bit more control to the front end of the car. They're saying that there's been some in the forums, they've been talking about how excited about this are. This is kind of a breakthrough for them. The new tire model feels more accurate to drive, permitting placing the car with more precision and absorbing bumps and undulations better with more predictability. All of this is now possible without any hits in terms of performance. So they've sort of gotten the holy grail here, where they've got sort of fast response times, good performance, and low overhead. And he calls it a miracle win-win for everybody. So they're just finishing up the balancing and testing the performances, so the lap times will remain more or less equal and general balance of the cars, and your setups won't change, but it will give you more precision, stability, and predictability of the tires both on and off the curbs. Now, one other point, and I think this is the last section. This is the last section. It's just a little bit off topic, but it does affect sort of tire traction, which we've been talking about. In block pane, in a passenger car, traction control can actually control, the throttle, the brakes, and other things sort of drive-by-wire. In block pane, the rules are such that the throttle traction control can only modify the ignition timing. So to better control, let's see what he's saying here. I kind of forgot this point. The traction control only modified the ignition timing, which lowers up to a point the engine power delivery. And if this is not enough, then it will start to totally cut the engine at high frequency, resulting in the characteristic engine rattling and vibration. Being able to lower the ignition timing before cutting totally the engine is very important, because it permits a more gradual power delivery and a more accurate control at the initiation of a slide, giving the driver the possibility to modulate the throttle application or work around the slide with steering input. So better steering, better traction, better feel for the car. All of this is now simulated in ACC, delivering a more advanced traction control intervention that not only makes you faster and safer. And they're saying that they really never thought they would be able to get this done, that they didn't see this as a possible solution. So bottom line, we go from 1 sensor point to 5. We still model all of the things associated with that, the heating and the wear and all of those types of things. The performance is better, and the ability to exit the corners is going to be better, because you're going to have traction sooner. Climbing over the curb is going to be better. It's not going to be a step function. It'll be more of a linear feel, which will give you force feedback sooner and more accurately as you go over curbs. The 3D model of the tire is going to allow for ride height changes. You may get better aerodynamics associated with it. So, and then the traction control is modeled for better feel and sort of knowing when to put the power down. So I'm really excited about 107, which is about to be out. I hope you guys will get into multiplayer and race with us and enjoy Assetto Corsa Competizione as much as I do. Please subscribe. Leave me a comment. Tell me what you're thinking. I heard VR and triples, and I saw a couple of videos. Talked to a guy, said it was working good. So I'm not on triples or VR, but if that's your thing, you may want to try it now. So thank you, everybody, for joining. Have a great night. See you on the track. Take care. Bye-bye.